Hello everyone, Mr. John here with a ZIML Brain Potion for April Fool's Day. So hopefully everybody is doing well today, and I want to go over a couple of proofs with you guys today. Starting with the warning at the beginning, right? So I'm going to do the rest of these proofs and the slides as kind of straight-faced as possible, right, as a teacher presenting these to you, but I want to get it over with at the beginning. Warning, all of the following slides are going to give you wrong proofs. We're going to end with 0 equals 1 on all of these proofs that I'm going to do with you today. We have a couple for you. And of course, this is false. This is not true, right? So the point of this video for April Fool's Day is, right, to try to spot where the error occurs and let us know in the comments below, right? So try to spot that error, see if you can see where things are going slightly wrong and how they end up with the totally wrong statement that 0 equals 1. So one last time, just to make sure everybody is clear, right? 0 is not 1, but now let's see some proofs that it is. First problem we're going to look at is this problem with this infinite sequence here, right? So you might have heard of infinite sequences, right? Or kind of infinite series if you're kind of adding them up, right? So we have 1, -1, 1, -1, 1, -1. That's our sequence. And then we want to ask the question, what happens if we add a bunch of this stuff up? So let's look at grouping this, right? So this is actually a method you might do in a lot of sequences, especially these alternating sequences of this form. So you group these terms together pair by pair. We have 1 minus 1. Everyone knows that's 0. 1 minus 1 is 0. 1 minus 1 is 0. 0. So we add up a bunch of zeros here. And it doesn't matter how many zeros you have, that just adds up to 0. So our final answer here, this sequence has a sum of 0. Okay, let's rewind this a second. So let me get rid of all of our stuff here. Let's go back to the beginning here of all of our zeros and everything, and see what happens if we group this a little bit different. So maybe you start kind of doing these sequences, right? You start calculating some things, right? I do 1, minus 1 is 0, plus 1 is 1. Maybe you don't notice right away, but then you start seeing, hey, I have a minus 1 and then a plus 1. So I want to group all of these terms in pairs like this. Now, similarly, 1, -1 plus 1 is 0, 0, 0, 0. So we add up a bunch of zeros. That's still 0, right? However many of those we have. But wait a second. We have this extra 1 at the beginning. And so now we have proven that our sequence is 1. Our final sum is 1 in this case. So putting this all together, what have we shown? Well, is one way of grouping better than the other? It shouldn't be. So one way gives us 0, one way gives us 1. So therefore, the only logical conclusion is that 0 must equal 1. So there we go, 0 equals 1, using this kind of infinite sequence that we're adding up in this case. Let's look at another example here using algebra and factoring. So here we're going to use a little bit of variables and stuff. So variables can definitely have values. So let's let two variables here, a and b, both are going to equal 1. Well, they're both equal to 1, so clearly a equals b. Now, what if we multiply by b on both sides, right? So if we have this equation, right, we're kind of multiplying by b on both sides of our equation. that should be perfectly fine there as well. So multiply by b on both cases. And let's just kind of continue doing some algebra on both sides. So if we multiply by b on both sides, now we can kind of subtract a squared on both sides. So we're going to subtract a squared from both sides of this equation. And now we have to see if you guys remember your factoring patterns here, right? So remember your kind of equations, right? We're doing a little bit of factoring here. One of these is, right, ab minus a squared is just equal to a times b minus a. This is just pulling out a common term. And also one of these very useful factoring formulas is our difference of two squares factoring formula there as well, right? So we have this difference of two squares where we're kind of looking at b squared minus a squared, and then that gives us b minus a and b plus a. So this is doing some factoring at this step here. And now, wait a second, we have the same thing on both sides, so cancel those out. And what are we left with? A equals b plus a, or subtracting the a from both sides, b equals 0. Well, what were these things? A has to equal b, right, in this case, but b equals 0, so 0 equals 1, right? So we started this with a equals b, which is true, right? But then b equals 0, but a equals 1, so 0 equals 1. Ta-da! We have another proof here that 0 equals 1 in this case. Now let's do a quick review of complex numbers. Remember that I is equal to the square root of negative 1. So this isn't a real number, it's not on your normal number line, but if you want to take square roots of negative numbers, you need some new symbol to represent that. So here I is this imaginary number equals to the square root of negative 1. So of course, our whole point of this is giving us a number that I squared, right? When we square that number, we of course need to get negative 1 in that case. So let's go through our problem then here. So of course, 1 plus 1, square root of 1 is 1. So let's just add square root 1 instead of 1 in this case. Well, now 1, remember if we have a number, right, 1 is equal to the square root of negative 1 times negative 1. So I'm just doing actually nothing here except replacing negative 1 by negative 1 in this case. And now here's where the important step in our complex number comes in. Remember we have properties of square roots. So remember that the kind of square root of a times b, if we have two numbers multiplied here, this is the same as the square root of a times the square root of b. And so that's the property here we're using when we shift and rewrite this 1 plus 1 equals 1 plus square root of negative 1 times the square root of negative 1. Well, don't we have a name for that? Sure, that is just I. So why not replace these as I? So I is the square root of negative 1. So if we go through here and substitute that in, right, square root of negative 1 I, square root of negative 1 is I, and hey, what did we say about I squared? Remember, I squared then is going to be negative 1. So I think you're starting to see how our proof is finishing up in this case, right? So this we have then our negative 1 plus 1. Let me fix my arrow a second here. And so these add up to 0. So in fact here we've proven that 2 is equal to 0, which, okay, dividing by 2, we have 1 equals 0. So in fact, now we've used complex numbers to show that 1 equals 0 in this case. Now, to end here, right, feel free to discuss the proofs below, right, and share your other kind of favorite false proofs or mathematical paradoxes or kind of, brain teasers. All of those things will go great for a kind of happy April Fool's Day, right? So let me write that on the screen here nice and big as well, right? Share a lot of those things. I always like to hear and kind of learn about the different proofs like this that aren't kind of quite correct. You have to puzzle out why they're right or wrong. Please share those below or kind of in our discussion on the ZIML site as well. Right, so remember, if you go to ziml.areteam.org, you're going to have free daily magic spells. These are free problems, monthly contests, all kind of other good stuff, right? Other brain potions, discussions from previous problems or brain teasers, things like that as well. So I really hope you guys join that community over at ZIML. Otherwise, please kind of like the video if you enjoyed this April Fool's Day content. Subscribe to our channel for more updates and everything, and I hope to see everybody soon. Goodbye for now.